So this study exemplifies the externalities that climate change is imposing into other actors, just using the same time of definition that we have been working with. And these losses are quite differential. And it is of some concern, I think, that when we think about Near East and North Africa, Africa and Latin America, which are the poorest areas in the world, they are taking the largest losses in terms of agricultural productivity from climate change. So this total factor productivity is taking the biggest hit in the poorest areas of the world, right? So look at Central America, look at the Caribbean, some parts of South America, all these parts of the middle and the northern part of Africa, some parts of the Middle East. They are taking the biggest impacts, negative impacts from climate change into the total factor productivity of agriculture, which accounts for an important part of the economy in many of these places, but also it's obviously associated with food security, food safety, avoiding people going into hunger and into severe droughts that can harm the possibility of livelihoods of many people around the world. So I think this is one more example of what we're talking. And this, I want you to connect it with the problem from the experiment we did last Tuesday. And I will show you more detailed behavioral data from your own particular decisions so that we can understand what's going on with the larger picture of the planet with this ongoing anthropogenic climate change created by humankind, how it affects the well-being of many people around the world, and how this idea that this loss of this equilibrium using this bathtub model relates to what we did in the experiment last time. And that experiment, if you remember, had to do with each of you holding in your hands 10 tokens and deciding whether to invest those tokens or keeping them for your own revenues. And if you remember, there were 20 players in the game, 20 of you, and for each token kept, you would earn 5 cents. For each token kept, for 5 cents per token invested and 50 cents per token kept, but also 5 more cents per token invested by others in the group. And each one of these 3 pieces of the incentives are going to play out the framework of material incentives that you're going to use in your decision whether to invest or to keep these tokens, right? So first, let me summarize key issues about this particular context of incentives. First, you have absolute power and control over your own 10 tokens. And therefore, you can guarantee 5 cents per token invested or 50 cents per token kept. And with those 2 first components of your earnings, and knowing that you have perfect power over your decisions because these 10 tokens are your own, you have absolute private property rights over those 10 tokens. And this is key in what we have been building throughout the course. If you remember the issue of institutions, property rights, power, you have absolute power over those 10 tokens. And if you want to maximize your own payoffs, for sure, this ratio of 50 cents per token kept against 5 cents per token invested will give you definitely clear incentives to keep the tokens. In other words, for every token that you invest, you are foregoing 45 cents in this first step of the problem, right? If you keep it, you guarantee 50. If you invest it, you guarantee 5. And therefore, the opportunity cost at this moment, in this stage of the analysis, the opportunity cost of that token invested is 45 cents. You give up 45 cents when investing one token instead of keeping it. And I can see clearly, you can see clearly that there are material incentives to keep that token. That's one part of the problem. The next part of the problem, which makes this tricky and interesting and fascinating, is this third component. Because you have no control, no power over what the other 19 players do in the game. But yet, you benefit from every token that the other 19 people put into the investment fund. And that's what makes this very complex, interesting. And this is what we call in economics the classical social dilemma or collective action problem. Because we already did the math last time, if all 20 players invest all their 10 tokens, we're talking about 200 tokens invested, and 200 tokens invested will give everyone 5 cents, which will mean $10 for each of you in that particular round. And you are much better off with $10 than if everyone kept their 10 tokens and earn only $5 guaranteed. So we can go individually from 5 to 10, but for that to happen, you need to solve the collective action problem, which is everyone contributing their 10 tokens. But the incentives are in conflicting ways. Because individually, each of you make more money by keeping the tokens and yet getting the benefits from this third component that I am highlighting there. Right? So we can agree that everybody as a whole benefit from everybody putting their 10 tokens into the investment, and yet there are individual incentives not to doing so. And that's the classic collective action problem. So what I want you to think is, which is this particular question, and I asked you that last Tuesday, tell me what kind of parallels do you see between the climate change problem and this particular game that we did? And I want to hear what you thought in this couple of days. Anyone? Any parallel between the game and the climate change situation? Anyone?
It kind of takes everyone to like invest, but you kind of benefit the most individually if everyone else invests and you're not the one paying the price.
Yes, that's what happened in the game. But tell me, how is that related to the climate change problem? Give me an example.
If other countries are all paying the price to deal with climate change and like you're not, then you reap the most benefits. But also if like only one person's pulling the weight, then not much change will happen.
So give me an example of a country doing exactly that.
If one country is like not worried about how much it's polluting, or like a majority of countries aren't worried about how much they're polluting, and then one country is trying to combat it and like taking those costs,
okay,
then the effect isn't gonna be that great.
Okay. And we'll be talking about combating, for example, emissions towards CO2 accumulation in the atmosphere. So yes, I agree with you, Joseph, in that there are incentives for a particular country not to do an extra effort into making its own energy transition. and yet it could benefit from many other countries doing so, right? Crystal, you were going to say something too. Do you have another example or another parallel in this case?
I was just thinking the same thing, that like it takes, the majority of countries contributing to make it have a net positive effect and not have everyone losing money. And if just a few countries do it, then they're going to be losing money until everyone can.
Yes.
But I was also thinking that like,
yeah, go ahead.
I was thinking that the countries that aren't, putting as much effort into it right now are also the ones that produce what fuels the countries that are able to. So that relationship makes it more complicated as well.
Yep, exactly. So think again, when I was saying that every token that you invest implies an opportunity cost of 45 cents, which is a lot compared to the 5 cents of you from the 5 cents for you from investing that. So what would you say could be an example of that opportunity cost of investing? Again, if you invest a token, you give up 45 cents from investing that token, because otherwise you would be earning 50 cents. What would be an example of that opportunity cost of a country with respect to the climate change gain? Anyone else? Maybe using what Joseph and Crystal said before, of these countries doing or not an effort. Which one would be an example of that opportunity cost?
Essentially like closing down like factories and like losing out on the money that they gain.
Exactly. And if you remember, I mentioned before this particular case of the Taranto town in Italy, who has been struggling between shutting down this huge factory that provides employment for everyone in the town, as opposed to keeping the factory, the plant, the production plant, with all its negative consequences to the environment. So you have to give up something. And the problem is that if everyone avoids those opportunity costs, we are going to end up all with only $5 of earnings when we could be at $10. And part of this that I want you to relate between the two situations, the two gains, is that the only way we can reap the benefits from this transition, let's say the energy transition, and many of you are writing papers on that too in this course. The only way we can reap the benefits from that energy transition is that we have enough players to chip in. And that's the point I'm trying to make. So in the game, and I'm going to show you the data in a second, more detailed data, the only way that it is worth foregoing those 45 cents per token is that you get enough people to chip in, to put those tokens in the investment fund so that you recover back those opportunity costs. And probably by now, you already did the math. How many people do you need to contribute, or how many tokens you need to be invested so that you recover back those 45 cents? Did you do the simple calculations? You need to recover back 45 cents. That means that for every 9 tokens invested by others into the investment fund, you recover back those 45 cents. Just 9 times 5 cents. And that way you recover that. So in a way, think about it. If you can convince 9 other people to invest one extra token, you will get your 45 cents back from your token invested in the investment fund. You see what I'm trying to communicate here? It's not that hard. You just need 9 tokens put into the investment fund so that you can recover your own 45 cents that you gave up to invest in the investment fund. And that's exactly the problem we need to analyze at the global scale. So when you were hearing Joseph and Crystal talking about countries, how many countries do we need? Or how many units of CO2 emissions do we need others to reduce so that you and the others together recover back the opportunity cost of, let's say, shutting down those coal plants, shutting down those thermoelectric plants, switching to electric transportation. So you need to do the accounting of the costs and benefits, and that's at the core of what we're doing in this section in the course. And this is why I wanted to do this game for you, because you can see clearly this. You can tell me, Juan Camilo, why should I invest a token and give up those 50 cents and in return get only 5 cents if I have no power over the other 19 people? And on purpose, I didn't allow you to communicate yourselves. We could have done it and the results would be different. And you can read about that in the text. And there are plenty of examples that communication works. But we're going to be doing that a little bit later. But for now, my response to that skeptical person that says, why should I invest and give up 45 cents to put a token in the investment fund if I can guarantee those 50? And besides, I am anyway benefiting from whatever the other people put into the investment fund. Why should I? But if everyone chooses that strategy as their best dominant or best response dominant strategy, the equilibrium of the game, the Nash equilibrium, which is, by the way, a dominant strategy equilibrium, will make everyone fall into earning only $5. When we all know that we are within the possibilities of making everyone $10. And let me show you more detailed data on that. These are the 5 rounds. And let me walk you through the graph quickly. This is the first round. And what you see here is the histogram, the distribution of decisions during that first round, in which you can see something's happening here with my PowerPoint. I think it's coming back. Hold a second. Whoops. You lost my screen, right? Did you? You're not seeing my screen?
No.
Whoops. Hold a second. Something happened here. Here. And let me go back again. And again here. And here. So notice, this is the first round right here. And this is the fraction of people who decided to invest 0 tokens into the investment fund. So somewhere about 30%. A third of you decided to invest 0. Okay? And these are the number of people who decided to invest all 10 tokens into the investment fund. And that was something like 25% or something like that, like a quarter of you. And all these in between, so these are the frequency, 10% of you decided to put 1 token, 20% decided to put 2, 3, 4, 5, okay? Now, notice what happened in the next round. So now in the next round, and let me erase this here. Now in the next round, notice this number of people went down a bit, but still 20% of you decided to put all 10 tokens into the investment fund. And the number of people who decided to put 0 tokens, in fact, decreased a little bit. But there were more people putting 6 or 7 tokens. And then look at round 3. Now in round 3, the number of people investing all 10 tokens, investing no tokens, so keeping all 10 tokens went up, and the number of people putting all their 10 tokens went down. And then round 4, this even increased more, and round 5, this even increased more. And by round 5, more than half of you were investing 0 tokens. So more than half of you were keeping all your 10 tokens at that 50 cents rate. And only 10%, which means one person, still in round 5, decided to put all 10 tokens. So you can do the numbers of how much money did this person, right? Because this means that this person invested all 10 tokens at 5 cents each. So that would be 50 cents plus whatever this person made from these few tokens invested in the investment fund. Because everyone else, more than half of you, were investing 0 tokens and keeping all 10 tokens. And this is what you saw in the graph here, which is this average went up a little bit and then began to go down, 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 and ended up there in the 5th round. Right? If we think about the aggregate numbers, which is a similar graph, we're talking about, and here's what I want you to see, that in the first round, out of the 200 tokens that you had all together as endowments, 200 tokens, you were investing somewhere around 70 something tokens in the investment fund. So everybody was benefiting from these 70 plus tokens invested. Everybody was getting the benefit from those. And then in round 2, it's even better because it was 80. So in round 2, notice 80 times 5 cents means that everybody was benefiting by $4 from those 80 tokens invested in that second round. But then those contributions began to erode and erode and erode. And by round 5, it was somewhere around maybe 26, 27 tokens invested in the investment fund. Now, there are 2 narratives that you can build on this game. And it is fascinating, it's interesting, and I have always wondered about this. Why is it that the way we tell this story conventionally in any textbook in economics is that free riding is what everybody should do, that the tragedy of the commons is what should always happen, and that people are homo economicus who maximize their own material well-being, and therefore nobody should invest that token in the investment fund because they will maximize those material benefits by keeping the 50 cents per token kept in opposition to the 5 cents from the token invested. But to me, the fascinating part is the following. Why is this so much prevalent in economics? And why we don't talk much about this particular part? And not only in the sense of you benefiting 5 cents per token invested by others, because this would be a quite individualistic approach to the problem. But notice, I could reframe the entire game in the following way, and I am not changing the slightest the material incentives. And what I'm going to say is the following. Each token that you invest provides 5 cents of benefits to you, but it also provides 5 cents for everyone else in society. So notice, if you invest a token, you make 5 cents for your own wallet, but you are giving 19 more people 5 cents for their wallets, for their income. You are providing this to society. This is part of the benefits that you are giving out to others. And if we frame that way, the situation, it could be the case that a human is evaluating not only how much do I get and how much do I give up, but how much do I give out to others and how much others are benefiting from my own actions. And it's quite a lot of money because, again, yes, if I invest a token, I give up 45 cents. But also, if I invest a token, I am producing 19 times 5 cents, which is $4.50 of economic well-being that is distributed out into the rest of society. And what we're going to be doing in the, not this week, but the week after, is thinking about what kind of economic rationality we need for a good Anthropocene, for the future 21st century. And thinking about the economic rationality is going to be crucial because, again, the conventional way that has been posted in most of the textbook in economics is that you should think only about this particular part of the problem, and this is seen as a problem of free riding. That's one approach. But also another approach, and I'm going to put it, you are wondering why, in green, this means also you produce 450 for the rest of society. And what we're going to be discussing later is what kind of economic rationality we need for the good Anthropocene to think about this particular problem of climate change and any other environmental challenges that we have ahead. And you probably remember from chapter 4 in our module on social interactions that humans care about other people. Humans care about fairness. Humans care about inequality. And in that sense, thinking in this particular problem, and in particular when looking at this data here, think again that these 70 or 80 tokens that individually each of you decided to chip in for producing well-being to others is where part of the solution relies on that capacity of humans to provide public goods benefits to others with many other extra features that we will be addressing later. That if I repeat the game, for example, allowing you to chat with each other, these blue bars would not decay as fast in the following rounds. In fact, these blue bars could go up because of key elements of human rationality that were operating in this case in your game. So I am pretty sure that many of these people who started with the 10 first tokens all into the investment fund, when saw in the next round that not everybody else was doing that, they decided to reciprocate back and say, if you're not chipping in, I'm not chipping in. But if you contribute, I am willing to contribute in the next round. And we have very strong evidence that humans act that way, and that you can get people through positive reciprocity cycles, virtuous cycles, increase the contributions towards the public fund, meaning the investment fund of those 10 tokens, and getting people make more money out of this. Plus many other variations that we can make in this case, in this game, that could account for or could explain how people make those decisions that you can see here in the individual decisions of each of you. And we can learn from that to go back to the major big environmental problems that we're addressing, many of which you are doing in your own research and for your next essay, with respect to energy, to food production, to sustainable businesses, to energy production and consumption, to the type of cars we use, deforestation, clearing forests, protecting biodiversity. So when we think about this particular problem of climate change as a public goods problem, which is the game that we did, we can think of many instances, and Joseph and Crystal gave us good examples, that in this case, the idea of contributing to the public good could be represented in many ways by these countries. It could be switching to clean energy. That is costly. There's an opportunity cost of doing that. Converting energy production plants that are already operating on coal, and coal is getting cheap. And then when coal is cheap, we can get coal to produce energy at a much cheaper rates and make those energy companies more profitable. If you need subsidies to get people to install solar panels in the roofs, that's costly, either because the government pays for that or people pay that within their own energy bills out of their pockets. Those both are opportunity costs of switching to clean energy. Switching to electric transportation, same thing. Buying an electric car is more expensive than buying a gas car. And I keep wondering about that decision now that I'm going to move to Amherst and I need to get a car for me and my family. And I am beginning to look at different prices and different criteria to decide which car should I buy. And this is one more of those elements in place. How much I am giving up in terms of money when I pay more for a cleaner car, because I need to balance that out with other expenditures that I need to make because I am moving and I am installing in a new home, I need to get furniture, so on and so forth. Think of protecting forests as carbon sinks. Yes, we know, thinking again into this problem, forests are key here, especially key here for absorbing CO2 or for storing CO2. But protecting forests for that purpose is very similar to thinking about one token that you invest into maintaining the token as a forest and getting those 5 cents, but foregoing 45 cents of clearing that forest and putting intensive agriculture into that to produce biofuels or produce grains to feed cows and pigs all over the world. Ecological restoration. We know that through ecological restoration, restoring forests, reforesting cleared land is important for trapping carbon from the atmosphere, but it is very costly as opposed to just leave the land clear with no vegetation. So here are the key elements from the game that I want you to get to appropriate from all these, is that any of these strategies and many more imply a significant private cost, and the private benefits are rather small. Again, it's like that token that you invest in terms of keeping it, and if you invest it, notice it's a huge cost because it's foregoing 45 cents and the benefits that you get from your own token, it's only 5 cents. And those are rather small. But the sum of so that's that first point. But the next point is that the sum of the contributions can create large private benefits for all. And we already demonstrated that with the game. Notice, again, one token that you stop in keeping and you put it into the investment fund, yes, it creates a 45 cents opportunity cost to you, but it also produces a $4.50 benefits to all. And that's a lot of money. It's just that your own particular individual action explodes in effects to everyone else. It spreads out into the others. But if the others are doing the same, at some point, and I already demonstrated 9 tokens, because 9 times 5, 45 cents, $4.50. So we will get sufficient returns from everybody else's contributions to justify my own sacrifice to take 1 token away from my private account and put the token into an investment fund. But for that, the bottom line is we need many people to contribute. It's not going to make a major difference if you're the only one in your neighborhood using solar panels. But as the use of solar panels becomes contagious among the neighborhood, and more neighbors begin to transfer, everybody begins to benefit from that. And there are many ways that benefits many people, because then the energy company begins to see the profits from everybody switching, because now you get enough energy production during the day that you can send back to the grid, for example. And that reduces the cost of operation of providing energy to other places. And then that energy company can supply the larger grid to other counties and sell energy to other places, or sell energy in other times of the day when the energy is not stored during the day because of the photovoltaic process. So there are many ways in which all these elements begin to operate and create this collective action situation in which everybody benefits from the contributions of many. But of course, without ignoring that from the individual standpoint, you still benefit from keeping your tokens and not investing them. Okay? So that is key to begin to think of the collective action problem, and climate change is a good example because this is the largest scale, but it's the most relevant of all for society and for the planet. And one last piece of information that I want to leave here with you that is based on that first part of chapter 20 that you read is the idea of abatement costs. Because for doing this, there are many ways of doing this. You can switch to clean energy in many different ways, and some are more costly than others. You can switch to electric transportation, but there are some more expensive ways than others, and so on. So the idea of abatement costs is to think of how expensive it is to stop these externalities, these damages. And we have now much more detailed and better quality data to think about that. And you read about that in that section in chapter 20. So again, this is a problem of opportunity costs. What do I have to give up to reduce these environmental harms? And which is the most cost-effective way of achieving certain goals? So if the planet is pursuing a reduction in 1.5 or 2 degrees Celsius in the temperatures so that we avoid disaster from too much global warming. So we need to find out how much total emissions we need from the planet to cap, to put a ceiling into that, and with that ceiling, be able to keep those temperatures low enough. So that's the aggregate tons of CO2 emissions. And to avoid that, to reduce those emissions, we need to find different ways to get to that, okay? So I want you to think for next week, for your particular research topic, which is the type of environmental harm that you are analyzing in your essay 2, because you will be doing that in your writing. Just as in the case of the banana production, it was the use of this pesticide that harms the health of the fishing and the health of the fishermen and the fishing people. Think of your case, what it is, and think a particular abatement policy, a policy that will reduce that harm. So for example, in agriculture, for the pesticide, it could be substituting pesticides with integrated management control of pests, with organic pest control, for example, right? And when we look at climate change, and with that I'm going to close, we know today that there are very expensive and much cheaper ways of reducing CO2 from being emitted. And this graph is quite telling. What I did is just turn it 90 degrees from what you see in the text. But you can see here that, for example, in the case of reducing deforestation or reducing pasture land conversion, is quite cheap to avoid in euros equivalent per ton of CO2 emitted, as compared to very expensive cases, which would be to refurbish or restructure coal power plants, retrofitting certain production of energy, which is quite expensive there. And within that, there are many different possibilities of reducing CO2 emissions. So this notion of CO2 abatement costs is going to be key for us next week, to start thinking about the valuing of costs and benefits from achieving environmental goals, which, by the way, was one of Crystal's questions, I think, last week, in terms of how do we measure these things if there are things we don't know how to measure. And we will be talking about that, because you are going to be reading that in the rest of chapter 20 for next week. So I'm going to stop there, and I will post the answers to the quiz sometime today, and continue reading chapter 20, because we are going to be working on this. And be alert in Moodle on my office hours to help you with the second writing assignment. So that's it for now, and thank you for coming to class this time, and I'll see you guys on Tuesday. Okay.
Thank you.
Bye-bye.
Thank you.